2, obviously. All right, and if you don't know, there it is, partial derivative. Okay, now this is what your assignment is going to be for the week. All right, we will get to discussing some of this in a little bit. But you're going to have section 1.5, 1.6, and 1.7 that will finish chapter 1. Okay, so, and after that, and of course, here's the numbers. This is in your, that should be in your syllabus, I believe. But, okay, and then we are going to do a quiz at the start of class. I think it's 7 problems or thereabouts. But we'll have a quiz at the start of class next week over the skills of chapter 1. All right. Now, one of the things I've been asked to tell you, this was reviewed and sent to you from time to time. You will have videos or tutorials or lessons that are in your gradebook assignments. All right. To access those links, you're going to right-click on the link because sometimes the links are not automatic. Right, and so you right-click on the link, and then you select Open in a new window. After you select Open in a window, the browser will give you another window, so your grade link will still be available to you. Right? If not, then what would happen is that you would open it in the same window, and then you would be kicked out of grade link, and you'd have to go back into grade link and then log back in again. Right? So this is a way to keep your grade link available to you while you're viewing a particular assignment that's in there. Okay, does that make sense? Okay? All right, now, next part is a quiz. Okay? This is from the work you should know. All right, I want you to name this expression with 2 words.
No, it's binomial.
Okay, so why is it a binomial? Because there's 2 T-words, 2 terms. There's 2 terms. This is one term, this is another term. So it's a binomial. And then what does the 3 tell you?
It's cubic.
Cubic. So this is a cubic binomial. Okay? All right, now, that's the vocabulary that you need to understand so that when you read it, if the instructions say, create a cubic binomial, or what we're going to see, create a trinomial. Right? If they say create a trinomial, what are they talking about?
3 terms.
3 terms. So what happens if they ask for a quadratic trinomial?
Then you have to have 3 terms with a degree of 2.
With a degree of 2, exponent of 2. Now, it turns out that if you have a quadratic trinomial, the exponent of the first term is going to be 2. The exponent of the second term will be 1, and the exponent of the third term will be 0. And any number to the 0 power is the number 1. We went over that last week too. You've got to remember that if something is raised to a 0 power, it's like it goes into stealth mode. That variable will not be shown. It's there, but it's in stealth because it's taking a simpler form. All right? So if I had this, what is the power of the variable that goes with the 9? The power is x to the 0 power. Because this is times x to the 0 power. How much is x to the 0 power? 1. What is 1 times 9? 9. And so the simplest way to show that is just to show it like that. But there is a variable associated with this. Right? That's something, again, it's an abstract idea, but it's something you have to recognize. Okay? All right, now, next one. 2 words. All right, we know what, certainly trinomial, very good. All right, 5. Now, all right, you guys probably have to do that, but back when I was your age, the big deal was multiple births. And a quintuplet were 5 kids from the same mother at the same time. Right, so this is a quintic trinomial. Now, how often do you need quintic? Not very often. Not very often. Because most of the time, they'll say this polynomial. so now this one takes 4 words. Because, first of all, what is the degree? Okay, the degree is not 6 because we have 2 variables. The degree is 8. So this is an 8th degree. 1, 2, 3, 4, 5. 5-term polynomial. Is an 8th degree 5-term polynomial. Now watch this. What are the exponents total? What's 5 plus 3?
8.
8. 8.
8.
8. If you have a normal polynomial that's of a high degree, these values will start descending from one and ascending from the other. So 2, 3, 4, 5, 6 is going up, and 6, 5, 4, 3, 2. Now, if this was a more typical polynomial, we would have 7 terms because we would have 6, 5, 4, 3, 2, 1, 0, and the last term over here would be y to the 8th. And the first term over here would be x to the 8th, y to the 0. Right? But for the term that I was trying to get you to do, I took that polynomial and just changed it a bit so that we got a 5-term degree 8 polynomial. Okay? And that's the vocabulary from last week. All right, questions? How often do you need that? Not that time. No. Okay? All right. Now, again, I had no communications with anybody having problems, and that's good. You shouldn't have very many problems. All right, so for sections 1, 3, and 1, 4, right, we were basically looking at some definitions of properties, and these are the 2 that are most important from that group that are sometimes not stressed in Algebra 1. The definition of subtraction you should have used until you got nauseated with it in Algebra 1. Right? The thing that I remember students hating the worst is if they had x minus 4, they had to make an entire new line and replace the x minus 4 with x plus the opposite of 4. So that you got used to understanding that subtraction is adding the opposite. Right? And it starts when you begin your work on integers, which should have been before freshman year. But this math is very helpful when you have a complicated distribution, because the negative sign out here goes with the 4 and gets distributed into every term. So if I have negative 4, let me put a 5 here, 5 plus negative 4 and 2x minus 3y plus 7. Okay? Because this is subtraction, order of operations says I don't do these first, I do the multiplication first. Alright, the first thing I have to do is definition of subtraction. This is plus negative 4. Now, what am I multiplying? Negative 4 times all 3 terms. So that will be 5 plus negative 8x plus negative times negative, right? 12y, and then negative times positive minus 28. Now, what goes together as far as like terms? The 5 and the negative 28 is negative 23. Because if the signs are opposite, this is plus, this is minus, you're going to get the difference. Right? I have a stack of 5 and I have a stack of 28. The first 5 make zeros, and I have 23 negatives in a taller stack, 23 negatives higher than this 5. So that's what that is. And then these two, because they are different, would be negative 8x plus 12y minus 23. Right? And what's important is understanding the definition of subtraction so that you're distributing the right number. Now, I was working with somebody last week, and this original problem that person was skipping over that negative 4 and was multiplying 4 times everything and didn't even see that it was negative and not positive. Right? So sometimes you miss those things from a reading standpoint, that your eye is going over, you're concentrating on the numbers and you forget the sign. Okay? And so to be able to train your eye, that's why what you should have done back in Algebra 1 or in pre-algebra, you should have gone and changed this to plus negative. So that you got used to understanding I've got to look at the sign, and sometimes I change it and sometimes I don't. Okay, does that make sense? Okay, so that's the first thing that we should have done. And that's close enough there. Okay, now, definition of division. Definition of division, if you have x over y, it's the same as x times 1 over y. Right, so, now why is that? Give me a multiplication fact that equals x. It's called the identity property. What does the identity property say? That 1 times x equals x. So there's a 1 here. There's a times 1. Right? What happens if I commute those? I can put the 1 over here. And isn't this times 1? And so what happens is I split them. Hard to do. And I have x divided by 1, which is x, and 1 divided by y, which is 1 over y. All right, now, we don't have to go through all that trouble because we have a definition of subtraction that says if I have a numerator over a denominator, I can switch it to the numerator times 1 over the denominator. Okay, so you can make that. That's an axiom. We believe it to be true without having to prove it every time. Okay, now, so this helps. The denominator becomes its own fraction. That's the whole big deal. Okay? Question on that. We're going to look at it here. I can get it. All right, so I know this is a little bit small. X squared plus 9x minus 4 times x minus 5. That look familiar? Right? We just did an example with that. So, this is the hard part. And be aware on testing. If it was all positives all the time, almost everybody would get them right. Okay? So, how do you make the test more difficult? One way to make it more difficult is to add subtraction and negatives. So while you're doing the polynomial work, you also have to do some arithmetic work with positives and negatives. Right? And so the more negatives I put in the problem, the more chance you have of making a mistake. And therefore, that test becomes, or that test problem becomes easier to separate abilities. People that get the subtraction problems and the negatives right all the time are your best students. People that sometimes get it right are the good students, and people that can't get them right at all have something to learn. And it doesn't matter whether they're good students or bad students. If they don't know what to do with this negative, then we got to go back to pre-algebra and get a fact and a process down so that they do know. And once they do know, then they're going to either be a good student or the best student. Right? Nobody in here is a bad student. We all have stuff we don't know. Right? There was a time when you didn't know 2 times 2 was 4. There was a time when you didn't know that. And hopefully, only 1 or 2 of you can't do this problem in your sleep. Right? After you get used to doing this negative, to where you say, and I use the basketball term slam dunk, right? This problem has got to be a slam dunk eventually. You've got to be able to understand that that negative goes with the 4 because it's the same as plus minus and negative 4, right? And so I don't even read that as a subtraction when I see it. I just put that negative with the 4, right? But I've been doing this longer than you have, right? Okay, so when we distribute here, we're going to get x squared plus 9x plus negative 4 times this, right? And so x squared plus 9x, negative 4, and then plus 20. And then these two combine into 5, and so this expression simplifies to this. And again, that's Algebra 1, right? And you should be comfortable at least seeing it, right? Now, are these things work? The answer is yes. This work. Now, how much work is the question? Right? This should be something that would be sort of like putting the dishes away. All right? Of course, you know, everybody, well, yeah, I guess, okay, taking them out of the dishwasher, right, and putting them away, right? My son hates doing that. We only have one, right? So if the child is doing it, it's him, right? And he hates putting the dishes away. Now, I don't like putting them in the dishwasher. I'd rather wash them by hand. And so, so a lot of times, there's dishes up on the little mat, right, that absorbs the water. There's dishes that are clean on the left side of the sink that I've already done. So he brings a dirty dish down, guess where he sets it? He sets it on the left side. It drives me crazy. Because where do the dirty dishes go? They either go in the sink or on the right side. Because I'm right-handed, and I wash the dishes, I rinse them off, and I put them over here, right? But he's left-handed, and so he looks at it completely different. All right? So, is this always easy? No, it's not always easy, right? But eventually, we've got to be able to handle that. And I'm hoping my son will eventually start putting all his dishes on the right side, okay? All right, so that is the review of everything up to here. So what we're going to do now is look at some of the things that are going to be new in the chapters that you're going to do. All right. First one is important for Forrester math. All right. Normally we would say x equals. There's no blue in my pocket. If we got finished, we would say x equals 2 or 7. Okay? What Forrester math for Algebra 2 is wanting to get you ready for is the solution set for this problem is the set of numbers that include 2 and 7. Okay? Now, so what does that mean? That means that instead of writing x equals 2 to 7, you're supposed to write s for solution equals and then put the bracket. And I think I told you last week this is a forward s followed by a backwards s. Okay? You have a forward s and a backward s, and you've got this. You have a backward s and a forward s, and you have that. Okay? Nobody practice that? All right. Anyway, you may have to now. Okay? All right. So, now, what happens if you write x equals the old way? If the answers are right, I really don't care. All right? Because what are we trying to do? We're trying to learn the algebra, right? But the Math 113 class, their assignment this week is sets. Everything that they do, they're doing set theory. So they're taking this and they're doing a 2-week lesson on that right there and what can be done with it. Okay? So there's a reason for you being told to put this answer in the form of a set is so that it connects with what's going to happen. Yes, sir?
They have not turned the bathrooms off yet, the water off, so that's another 2 hours. So you'll need, if you all need to go, you need to go down.
Okay. All right. Okay. We'll take. Well, if you need to go and you haven't gone I think I told almost everybody. Or anybody need to go? Go now. Okay. And I'm a teacher. I don't go till 1 o'clock. Okay. All right. Okay. Now another thing. Null set. All right. Suppose that I ask you where two parallel lines intersect. Where do two parallel lines intersect? They don't. And so the set of points where two parallel lines intersect is empty. There's nothing in it. Okay? So this has got something in it. What does it have in it? A 2 and a 7. This has got nothing in it. So that's how you report it. Now, there's another way to write this empty set, and that is to write a 0 with a line through it. This is called the null set. This is called what? The null set. And so by inference, it's talking about a set with nothing in it. Okay? Now, one of the trick problems would then be this. What is this? This is the set of symbols that includes the null set. Okay? So it's not the same as this. So I would have something like this if I were doing it. Okay? Alright, now this begins to make a little more sense. What is this a set of? It's what? Right. It could be transcendental numbers, or whatever that word is. But at any rate, but at least they are symbols, right? This is the symbol pi, right, which also happens to be a Greek letter, and this is the symbol of null set. So this is a set of symbols that you might use. That's different than the empty set. Now, I could make that teaching over and over again from different standpoints, but that's the basics. Is that if you're going to use set, you just leave it empty. And it's called the empty set. If you want a shorthand form of it, you use the 0 with a line through it, and by definition, it's called the null set. All right? If you put the two of them together, it's the same as, I used to always like this one. If you're doing composite and prime numbers, what is 1? Composite or prime? The answer is it's neither. By definition, 1 is neither composite nor is it prime.
Trick question scared me.
So, well, but again, if you're forearmed, you're forewarned. Right? If you understand that one of the trick questions they could ask you would be putting these two together, if they put the two of them together, it does not mean either or. It means something completely different. Okay? Does that make sense? Now, next part. And I introduced this a little bit, but when you get binomials, what's a binomial? Two terms, right? Now, most of the time, the binomial will be linear. That means the exponent will be 1. Okay, now, later on, we're going to get into quadratic binomials, right? And cubic binomials. And there's a formula you have to learn for those. All right, but when we have linear binomials, you're going to get something like this. In order for these three to be multiplied together to equal 0, one or more of those terms has to equal 0. Okay? Now, so here's the question. What will make x? What value of x will make this into 0? And what you're going to do is you're going to take 3x plus 4 and let it equal 0, and you're going to move the numbers to the other side so that all you have left is x.
Yeah.
All right, now, using algebra, what's the first thing I move?
Subtract 4.
The 4. How do I move it? Subtract. So that means I'll have a negative 4 over here. What do I divide by?
3.
So x is equal to negative 4 divided by 3.
Oh, wow.
Isn't that easy?
Yeah.
Okay, so now let's this. What's the first thing I move?
The 9.
9. How do I move it? Add. So it'll be 9 divided by 2.
Oh my gosh, I understand.
Okay? All right, third one. What do I move first? The 1. When I move it, it's -1 divided by 5. Negative 1/5.
Don't erase this one.
Okay?
No,
All right. Now, that's what two-step algebra problems way back in the first couple of chapters of Algebra 1, two-step algebra problems were supposed to get you that information so this doesn't scare you. Now, what happens? Two-step algebra problems we stopped doing after chapter 2
yes.
of the algebra book. And we didn't bring it along with us, and so we look at these, oh my God, what am I going to do? Right? Well, it's very simple. The reason for the two-step algebra problems was to carry that skill so that this is not hard. Now, now my answer is the solution set of -4/3, 9/2, and -1/5. And you should know that the negative could be in front. Right? Okay? That makes sense?
Yes.
Okay, now, that's the easy one. That's the easy one. So, what do we do? What do we do if we have this? Okay? This is the one I like. It's fun.
Oh.
This says x equals -2 divided by 9. Now, how do I move the 2 and the 9 over to the other side? I first have to
You have to multiply the
multiply by 9 to get rid of the denominator. That makes this 9x. And then how do I move a -2 to the other side? Add. So this becomes 9x plus 2 equals 0. That's what that is.
I love understanding things.
Okay? Make sense?
Yes.
Okay. So let's do this one. First thing I move is 3, so by multiplying, that'll be 3x, the 5 minus 5. So this one is 3x minus 5 equals 0. Okay? 12x plus 7. Now, let's just pretend that it was only these two. What is this? That's two binomials. Foil those and you can get the equation. All right? 3x times 12x. 36x. -5, yes, x squared, thank you. -5 times 7, -35. All right, inside, -60. Outside, 21. -60 plus 21, I have to subtract. 9 is 30, 39. Minus 39x equals 0. That's the equation of the line that has just these two as a solution set. That's Algebra 2. That puts all those skills back together into solving one problem. Okay, now, this ought to blow you away right now.
It is.
Okay, that ought to be overwhelming.
It
right?
is.
But what I tried to show you is this is where you're going. So that it's even worse. You know where these answers come from? They come off the graph.
Oh, yay!
See? These come off the graph, so you have to make the fraction or the whole number and then go through that whole process. But that's a high school level problem. Right? It's not beyond your ability, but right now it could be beyond your knowledge. You see the difference? Right? So if you see this is what's going, now when you see these particular answers given this way, there's a reason why they did it, because we're getting ready to do what in essence is an Algebra 3 problem.
Oh my gosh.
Because in Algebra 3, you have a set of multiple steps.
I didn't know about that.
Yes. Algebra 3 is easier in this fact. You're not doing as many things, but you're doing them deeper. There's a skill called matrices. If you do a matrix with 3 variables, x, y, and z, one answer will take you an entire page, sometimes front and back. One answer. what's nice is that there's a computer program that does a lot of the math for you. But back when I taught it, we did it all by hand. And it's interesting. But, and this is the thing, all of the great math scholars, they did it all by hand. And they figured it out. The guy that figured out algebra, you know what his name was? Algebra.
That's so.
That was his last name. He was from the Middle East, right? And his name was Algebra. And what his first name is, I don't know. But that's where it came from. That algebra that guy did. You know? That's, which is cute, right? Okay. All right. Now, okay, so, all right. I hope that, let's go back here. Let's go back here. All right, so we're going to learn to put these values into a set form of answers, right? And doing this is just doing a two-step problem where this equals 0. Now, because I didn't have you for Algebra 1, my best Algebra 1 students, we used to use the term, when I jump this to the other side, what happens to it? If you jump this to the other side, the sign will change. So this is a positive 4, it becomes a negative 4 over here. For the same reason. How do I move it? I add negative 4 to make this 0, and I'll have and a negative 4 will pop up over here. So we just used a different term. We said if I take this and move it over here, it's negative 4, then I divide by 3. So negative 4 over 3. Take this and move it over, it becomes positive 9 divided by 2. Now, none of these could divide. If this had been a 3, it would have been positive 9 divided by 3. 9 divided by 3 is 3. Right? So there could be a second step here. Right? But now, this is the one that sets you apart. If you can see this and understand how to get these binomials, you are at the top of your game.
Oh, yay.
Okay? Does that make sense? So this is what we want to be able to do. We want to be able to see this and be able to figure out what it came from. Now, what do we do first here? We did add, subtract, and then multiply or divide. How do I undo it? I do multiply first and add second. Right? So I multiply by 9 and I get x times 9, and then I add a 2 to get that to the other side, so this becomes 9x plus 2 equals a 0. All right, but again, this is introduction. This is introduction. If this stays in your brain a little bit, when we get into actually doing them, that's going to be, all of a sudden it's going to pop up. Oh, I remember when we first did that. Okay? All right, now, so now we're going to talk about inequalities. Okay, inequalities work like equations, except if you're multiplying or dividing by a negative number. Okay, now, how do you prove that? How do you prove that? Let's do this. I'm going to show you. All right, let me get, now this is going to be real impressive. Now I have a blank screen. Okay, so let's say that I have 2x minus 4 is greater than 12. All right? Okay. Now, this right here, I'm going to end up multiplying by positive 2, so I'm not going to have a problem. Right? I'm going to do what? Add 4. 4 plus this is 16, divided by 2. X is greater than or equal or greater than 8 would be this problem. Okay? Now, I'm going to change it and put a negative sign here and a plus sign here just to make them different. Negative 2x plus 4 is greater than 12. want that. I want positive. So I'm going to add 2x to both sides. This is 0. Right? I don't want the 12 there. I want the 12 over there. So I'm going to subtract 12. Now, what I have is negative 8. And when I divide by 2, I get negative 4 is greater than x, or if I read it backwards, x is less than negative 4. Okay? All right, now that's normal. All right, if I do this and subtract 4, that makes this 8, negative 2x and 8. When I divide by negative 2, I get x and negative 4. All right, if I copy this sign down here, is it the right answer? No. So in order for the math to work, when I divide by a negative, I have to flip the sign. Otherwise, the math doesn't work and there's no reason to do it. Okay? So, if you're unsure, use adding and subtracting and move the variable to the other side, and then the math will work. Right? Because now I'm dividing by 2, so I don't have to flip the sign. Right? But in order for this to be the right answer, I have to flip that sign. Okay? That's the whole reason that we are doing inequalities, is to be able to come up with the right answer. Okay? Yeah, let me, because I used black, I'm gonna have to clean. All right, questions on that one? Okay, now we get to the fun part.
Yay!
Yeah.
I have like some sneaky suspicion that it's not going to be that fun for us.
No. No. What you're going to get is absolute value.
What I guess used.
Is that it? No, that's the other class. Sorry. Here we go. Okay. All right. Before we get to that, greater than or less than, open circle. Equal sign, close the circle. All right. You should know that when this becomes important, when you have to write the inequality. Okay. Now, another thing that's in there that's very important, they don't use the word discrete. The word discrete is talking about whole number values. Okay? If you put x is less than 4, unless the domain of x is either called integers or it's discrete, then you would have all the fractions as well. And this line would be solid. If it's discrete or if it's integers, then you have a series of dots over the whole numbers or the integers. Okay? Now, this is the part right here that I think is fun. Okay. Absolute value. Absolute value is always positive. All right? So that means whatever happens in here, with the answer is going to be negative 45. But before you changed it with absolute value, it could have been negative 45, and then the absolute value marks changed it. So that means you have two things. You have 5x plus 20 equals negative 45, or 5x plus 20 equals 45. This is called a dual equality. And you treat it like an equation, except you're going to do things to all three parts, not just the two parts. Okay? So what number do I have to move to solve for x? What number do I move? Move the 20. How do I move it? Subtract 20. So I'm going to subtract 20 here, subtract 20 here, and subtract 20 here. So now I have 5x in the middle equals two negatives, add them together, 65 negative, and subtracting these equals a positive 25. Divide by 5, divide this by 5, divide this by 5, and divide this by 5, and we get x is equal to negative 13 or positive 5. 25 plus 20 is 45. Negative 65 plus 20 is negative 45, and the absolute value of that is also 45. Okay? So this is dual equalities. Right? Now, when we get to inequalities, we're going to do the exact same thing. All right? So, knowing that, what are we going to do first? Subtract the what?
The 20.
Subtract the 20, because I want to get the x by itself. So to move this, I've got to add negative 20. And then negative 20, and negative 20. And then divide by 5. Because I'm dividing by a positive number, I don't have to switch the signs, I copy them. Right? And when I do that, this is, again, will give me negative 13 greater than x greater than 5. Now here comes the hard part. How do I graph that? X is less than 5. Okay, now what I like to do when I look at when I look at an inequality sign, the closed end goes to the smaller number, the open end goes to the bigger number. So if I read this backwards, x is bigger than negative 13. So, where is x bigger than negative 13?
Everything past it.
It's here going this way. Alright, where is x less than 5? It's here going the other way. Right, 0's here. And so what I have is this line with two open circles. And when it's written like this, in order for it to be true, it has to be within this range. If I get out here, I'm only true for half of it, not all of it. So this becomes like a line segment, right? If these things are switched, where is x greater than 5? Here, this way. Where is x smaller than negative 13? Here, this way. So when they're set up like this, or, I'm on one or the other. This is and. I'm on this one, and I'm on this one at the same time. Right? So, this is called disjunction. And this is called conjunction. All right? Now, these are fun. All right, now, did you notice how I graphed that?
Yes.
How many points did I use? Used 3 points. I used this number, and 0. That's all I put down. Didn't have to gauge. See, how would you like to do negative 13 little lines then? You know, that's crazy, right? So when you graph something, that's what you're going to look at doing, right? So how would you graph this? X is greater than negative 2 and less than 7. How would you graph that? Okay, you're going to start with a line. All right, which number is going to be on the left? Negative 2. Put a line and put negative 2 under it. The other side is 7. 0, I'm not going to put it in the middle because it's not, so just put it right there.
Yes.
Now, what do I do with this sign? Without the equal, it's an open circle. This is an open circle. Now then the question is, am I going to connect the circles or do I go on either side? All right, let's read it. X is smaller than 7. Where's that located? It's located in here. X is bigger than negative 2 is located in here, and so therefore, they're going to come together.
Yay!
All right? Fun?
Yes.
Cool. All right. Questions?
Nope.
No? Questions? You can't answer. I can't hear you. Say it louder.
I was so confused for a second. I was like, who's he talking to?
Yeah. There's another group that gets this tape, and they listen to us.
Hi, guys.
Yeah. Okay. Now, all right. Next thing. Reflexive, symmetric, and transitive.
Yes.
In the memorization of what I call the Capi properties, CADI for commutative, associative, distributive, identity, and inverse. All right, the Capi properties, the addition here, R, S, and T have one thing, two things, and three things. Right, so the reflexive property is the first of those R, S, and T, so it's just X equals X, one and done. All right, now, because this is always true, I can introduce that in a proof. And I can introduce X equals X and say, why? Reflexive property. Okay? This one says, if X equals Y, then Y equals X. If I don't want the X here, or if I want the Y to be first, I flip the whole terms. Well, in this case, I'm flipping the whole expressions, all right, and changing sides of the equal sign. That's called the symmetric property of equality. All right? And then the transitive, which is the third of this list, takes three things. If X equals Y and Y equals Z, then X equals Z. Push them all together. It's a train. T for train, right? It's set up as a train. The first one and the last one come together when you couple them. All right? And so they're going to overlap. Some people say you substitute. Right? But if you have this, and in proofs, this is important, the transitive property, because you start with something, and then you end up with something, and so therefore you can say this X is equal to this Z. Right? And so now, proofs are not being stressed in this class. They were a bear. What's that mean? What are bears?
Big scary monsters.
Big, scary monsters. The bears will eat you before they smile at you. Right? And proofs were really a bear. They were really tough. Especially, and I said this last week, the younger you are, the harder it is for you to get your mind around abstract thinking. Right? The more you're exposed to it, the easier abstract thinking becomes. And so the proofs in freshman class are really tough because it's hard to get your mind wrapped around it. Okay, so that's the last thing there. What are we doing time-wise? Well, we're doing great. Okay, proving the multiplication property. Now, this is something you're going to have to do for your lessons this week. Okay?
I'm scared.
I'm ready.
All right, now, we're going to prove the multiplication property of equality. Now, what does that say? That says that if X equals Y, then X times Z equals Y times Z. The multiplication property of equality was something that you had to memorize.
Yes.
All right, well, that's different than proving it's true. Okay? Now, here's how you prove it's true. All right? I'm going to give you that X equals Y. All right? And then I know, because I'm a math scholar, that X times Z equals Y times Z, because that's the symmetric property of equality. Of the R, S, and T. Here's the first, here's the second. So the symmetric property of equality says this is true. Right?
Yes.
And now, by substitution of this X for a Y, I have this. And therefore, if X equals Y, then XZ equals YZ. And I made a mistake. I made a mistake. Yeah, so you're going to see the change. If I can get to it.
Learning experience.
Yes, it is.
Makes more sense.
Oops. Thank you. I'm gonna- It's the reflex. It's the reflex. Now, do you know how when you would make a mistake? Remember what I told you? There's 1, 2, and 3,
Yes.
right? How many is this? It's 1.
Oh, yeah.
This is 1, right? Because this was given. So I'm introducing this as a standalone. It's just the one thing. That's why it's reflexive. All right. Now, if somebody as old as I am can make a mistake, is it okay for you to make a mistake?
Yes.
Sure. Happens all the time. Right? Happens all the time. Now, when you don't want to do that is on a test. Right? But it happens from time to time, especially if you begin to start thinking ahead of where things are going. Sometimes you write, and I said this to somebody, I forget who it was. Number one mistake in algebra, in math, in high school. What's the number one mistake? You don't know? It's copying wrong.
Yes, that was me.
The number one mistake in algebra is copying wrong. Either you copy it wrong from the book to your paper, or you copy it wrong from one line to the next line. Right? If you make that mistake, you doom that problem. Right? And your math, your algebra is perfect. But you don't get the right answer because you made a copying error. All right, again, after 22 years I knew it before that, but after 22 years of teaching, that's the one thing you have to be careful of, is that you don't make a mistake copying. Okay? All right? Now, what's QED means? It is thus proved.
Wait,
QED, it is thus proved. All right? I don't know. It says so in the book. Read it.
what's that sound?
That's part of proofs. So, one of the questions that you might get is, how do you prove the multiplication property of equality? Because we're not stressing proofs, in my opinion, it's not fair to test you on that without having shown you what it's asking for.
Yes.
Okay? All right. Now, any other questions? Okay. All right, what? Oh, you're not done? Okay, I'm sorry. I'll leave it there.
Thank you so much.
Okay, I'm going to move to this side and show you how versatile I am. Okay. All right, good. All right, now. All right, so what I'm going to do now is we're going to go back and just review what we have been doing today, besides having fun.
We always have fun.
Okay, all right, now, so, all right, in week 2, these are the assignments coming up. Okay, all right, equations. All right, one of the things you have to remember about an equation, the answer is not x equals, it's the solution set equals, and then the set bars. Okay, remember that's one of the changes. Everything else in equations you really have already had. Okay, so because it's review. Inequalities. All right, I showed you with absolute value marks. All right, inequalities are exactly like equations except when?
Negative.
When you are multiplying or dividing by negative. So the number that you're supplying has to be negative. Now, how do I get people to get tricked?
Switch.
All right, switch, yep, that's exactly right. All right, let's see. Let me get away the word. Here, there it goes. What happened? Up to the third one, don't I? Oh, I must have texted out. All right, let me go, I can do it again. All right, here we go. So, here's how I trick you. Here's how I trick you. All right, do I flip the sign?
Yes, because you're multiplying with negative, right?
All right, okay, so that's exactly what I wanted. I got yes and no at the same time. All right? Okay, so one of them is not right. Okay? All right, okay, so let's go mathematically. What do I do mathematically to get x by itself?
You divide
Divide by positive 3.
Yeah, so you want to put this in.
Right? So am I dividing by a negative?
No.
No, therefore don't flip the sign. Okay, now, so you see the difference?
Yes.
It's subtle, right? It's not that there's a negative in the problem. It's that if I introduce division by a negative number.
Got it.
Okay? So because I use positive, I'm not going to flip the sign, and x is going to be greater than -5 when I simplify the math.
Right.
Okay? Now, and again, how do you find out if a student has that thinking down or is still a little bit confused in it? Is number one, you test them on it.
I got it now.
Okay? But once you understand what the trick is and have a fall for it, then you can arm yourself, don't fall for that trick. Because I'm supplying division by a positive number, so the sign doesn't flip. Okay? Should charge you extra for that. Except I haven't even eaten breakfast yet. Okay, and this isn't even ours, so I gotta get the other one.
Oh, thank God.
We'll be trying to fit in.
Oh, theirs is easier than yours.
Oh,
Hey, no fair.
It is, it is.
really?
They're set there. Remember I told you before, Algebra 2, in my opinion, is the hardest class because there are so many different things to do. All right, the Math 13 class is doing set theory, and then going to do logic, which is a form of set theory. Right? And after that, they're going to be doing equations. All right? So, I mean, you know, let's go there. You could probably go there and hold your own right now.
Cool.
Right? But what you're doing is you're getting the broad base in Algebra 2 of a whole bunch of different things. And what you're supposed to do is the same thing I tried to tell you about the Algebra 1 skills that you're supposed to bring into Algebra 2. Right? You've got a bunch of Algebra 2 skills that now you can take to a varying number of different higher algebra problems and higher algebra classes, and you'll use part of that information to be able to get those answers. So they have less to learn, but the level is harder. Okay? All right, so we're doing that. You're going to have a graded, I think it's 7-problem quiz next week over chapter 1. Okay, then we're going to do the review. In class, we'll do the review for chapter 1, and then you'll take the test. And my understanding is that you'll take the test at home without help, and then you'll bring it in and I'll grade it.
Yes.
I believe so. That's my first time, so I'm hoping I'm getting that right. Okay? All right, and it is 14 after. We have got finished with 30 seconds to spare.
Thank you.
Okay, have a good day.
You too. 30 seconds to spare. Come on, kids.
I'm going to turn this on.
Hustle, hustle.
Start, stop.